Everyone, we're moving on to 5.2 today. This will be the last page of your homework. We've had 2 days on the same homework. This is actually a 3-day homework assignment. I want to start out by saying these next couple lessons are going to get a little tricky. They're not the easiest lessons, so I understand that. Don't get frustrated if you don't feel like you're doing super well. That's what I'm here for. Come into my office hours if you have questions. I'm more than happy to help you. If this, after you watch this isn't making sense, maybe even still worth coming into those live lessons as well. All right, we're going to dive in here. Not trying to scare you with that. I just want you to know, don't lose confidence in yourself just because of maybe a few questions or difficulties that you're having with these, because these are some tough lessons we're going through. Okay. So I got a little warm up here to start. Today we're talking on 5.2 fractions and decimals. First thing I want to do is write these decimals from least to greatest. So I'm looking at them right now. The first thing that I'm going to pay attention to is how many zeros they have, because I know the more zeros that they have after the decimal point, the smaller they're going to get. I notice this one has 1, 2, this one has 1, 2, this one has 1, 2, this one just has 1. So I immediately know that this one is the largest. It is a whole place ahead of all the rest. So I'm going to start by just putting this one down here as our largest. All right, next up, I notice that these all have 2 zeros. So I'm looking for the next number after that. We got a 4, and a 5. This 5 is going to be bigger. So I'm going to write that one down as the next largest. Now I'm down to these two. We know they match on the 4. We look at the next number. We have a 5 and we have a 4. This one has a 5 after it. This one has a 0 after it. But that doesn't matter because this 5 is bigger than this 4. So this is going to be our next largest number. And we don't even need to include this 0, actually. Don't need that. Doesn't matter. So notice that it doesn't matter how many numbers are after. Our biggest number actually has the smallest amount of numbers in it. And finally, this will be our smallest, 0.00445. And that would be from least to greatest. All right, 2 terms that I have for you working in your notes right now are terminating decimal and repeating decimal. Maybe some of you have heard of the movie The Terminator, things like that. Terminating basically means to end, and the Terminator more so has to do with a different kind of ending, but we won't talk about that. Terminating decimal is a decimal that comes to an end. And a repeating decimal, if you can guess what that would, it repeats forever and does not come to an end. Those are our 2 differences there. We got a terminating decimal, comes to an end. What you've seen the most of, all of these up here are terminating decimals. Repeating decimal does not come to an end. Here's an example of it, 0.9999999 forever. And you can write these as putting a line over whatever repeats. So right here, the 9 repeats a bunch of times, so we put a line over 0.9. That means repeating. That is the repeating symbol. That might be worth putting in your notes as well. All right, so we know we have our terminating decimals and we have our repeating decimals. We'll see a little bit of both of these as we go through the lesson. First thing I want to look at, writing our fractions as decimals. So our fractions, we really know what that means is a division sign. So we have 5/8, but it really means the same thing as 5 divided by 8. That line right there, that fraction side, it means the same thing as divide. So we're going to set this up. 5 divided by 8, our first number goes on the inside, second number goes on the outside, or your bottom number goes outside, top number goes inside. That'll be true of all of your fractions. That won't ever change for a fraction. The big top number goes inside, bottom number goes on the outside. Okay, so right now I'm going to start doing this division. We've done some decimal division before, so you have your strategies for doing that. I'm going to do mine using the standard form here. So I see 8 goes into 5. How many times? 8 does not go into 5, so I'll put a 0 up there. I can put up that decimal point right now. Okay, so now I can pretend that decimal isn't there. How many times does 8 go into 50? Well, I'm thinking 8 times 6 I know is 48. So I'll toss a 6 up there. Subtract here. I have to pull this over, make this a 4, make this a 10. And we're going to get 2 left behind there. Okay. Those ones cancel out. We get a 0 there. 8 does not go into 2, so I pull down a 0. 8 goes into 20 2 times. Shouldn't put that arrow there. As 16. Subtract those, we get 4. 8 doesn't go into 4, but 8 goes into 40 exactly 5 times as 40. Subtract to get 0. 0.625 would be how you'd write that as a decimal. So really, we just did a division problem. We did our decimal division just like we learned a couple weeks back, and we found this right here. I'm going to give you a couple more examples of that, just a quick refresher here. So we know 3 over 4 is going to be the same as 3 divided by 4. Top number goes on the inside. Bottom number goes on the outside. I like to immediately put in a bunch of decimals just to get myself set up there. Just putting a bunch of zeros after there. 3 does not go into 4, so we know there's going to be a 0 to start, putting that decimal point. 3 does go into 30, though. How many times does it go into 30? It goes in 7 times as 28. Subtract there. We're going to get 2 left behind. 4 doesn't go into 2, but it goes into 20 5 times as 20. Get 0. 0.75 is going to be our answer. Pretty simple stuff. We're doing that decimal division. All you really got to know is that these are division problems. We'll do one more here. 3 divided by 5. Set that up. Top number goes on the inside. Bottom number goes on the outside. Put those decimal places in there for myself. 5 does not go into 3. 5 does go into 30 6 times as 30. 0 left behind. There's your answer. Easy enough. All right, we're looking at some mixed numbers. This is going to be pretty much the same. The thing to know about mixed number is the front number is before the decimal. So when I'm solving this, I already know that it's going to be 1 point something. It's going to be 1 point something as my answer. I don't need to worry about the 1 anymore. I can just worry about this decimal right here. So I'm going to do my 7 divided by 8. I know 8 is on the outside, 7 is on the inside. Top number on the inside, bottom number goes on the outside. Put my decimal points in there. That's going to be your biggest tip for these, just getting those decimals in there right away. Toss my decimal up there, doesn't go into it. 8 goes into 70. 8 times is 64. Subtract that. We're going to get 6 left over. 8 goes into 60. 5 times, oh, excuse me. 8 goes into 60. Yeah, 5 times. As, oh, wait, 7 times. What am I thinking? I knew that didn't seem right. 7 times as 56. All right, 4 left behind. Carry down to 0. 8 goes into 40. 5 times as 40. Subtract there. Here's what we got for our decimal point. We're going to add that on to our 1 that's already sitting in the front here. So we're going to get 1.875. Notice I just carried down that 1, and then I found the decimal for this and brought it down to there. 1.875. All right, we'll do one more example of these. So we got 3. We're just going to carry that one right down, put the decimal point after it. 3/10. 3 goes on the inside. 10 goes on the outside. 10 doesn't go into 3. 10 does go into 30. 3 times as 30. Remainder 0. This is going to be this right here. We bring that down, toss that on there. It's a little bit of decimal division right there. This lesson might end up being a little bit longer because we got a lot to it. All right. We're going to do this the same way, but sometimes you're going to have a repeating decimal. And once you get to the point where you notice, wow, this is going on for a really long time, it's never going to change. You know it's a repeating decimal. That's when we're going to use this symbol that we talked about earlier. You'll see an example of that right here. So we got 2, 3. That's going to be the same as 2 divided by 3. 2 is on the inside. 3 is on the outside. Toss in those zeros. 3 goes into 20. Does not go into 2, but goes into 20 6 times as 18. Subtract 2, pull down to 0. 3 goes into 20 6 times is 18. Subtract 2, pull down to 0. 3 goes into 20 6 times as 18. Subtract 2, pull down to 0. I think you're going to get the gist of it. This is going to go on forever and ever and ever. So we have our first repeating decimal. Woohoo! So this is going to look like this. Just going to keep going forever and ever. So our way to write this is going to be 0.6. Toss that line on top. That means repeating. One more example here. This is really going to be 15 divided by 11. Notice here we have a bigger number on top than on bottom. This we can also write as a mixed number, which you'll see here. So we're going to put our top number always goes on the inside. Bottom number goes on the outside. Put those decimal points in there. 11 does go into 15 one time as 11. Subtract 4. Pull down to 0. 11 goes into 40. I don't know why I put that point in there. 3 times, that's 33. Subtract, you get 7 left behind, pull on a 0. Goes in 6 times, that's 66. Subtract, pull on a 4. Pull on a 0. 11 goes into 40. 3 times is 33. Subtract, pull on a 7. Pull on a 0. Goes into 70. 6 times is 66. And this is going to continue forever and ever. Notice we don't have the same number repeating. We have the same 2 numbers repeating. Take a look at that. So watch what I'm going to do here. I'm going to write this as 1.36, and I'm going to put this line over 2 numbers instead of 1. That's how you write in those repeating decimals. All right. Ordering fractions and decimals. It can help to write them all as decimals. This is very true. So watch what we're going to do here. We have a decimal right here. We're going to leave that one. We need to change this one and this one into a decimal. 1/4. I have a quick tip for you. If you can ever make these equal to 100 on bottom, it's going to be a really easy way to make this a decimal. So watch what I'm going to do here. Times this by 25. Times this by 25. I'm going to get 25 over 100, which I can make into a decimal very easily. 25 over 100 is going to be the same as 0.25, 25 hundredths. When we're saying our fractions correctly, when we say our decimals correctly, we can figure that one out. So this is going to be 25 hundredths right here. Looking at this one, we can do the same. If we can make this to 100, which we can in this case, we can multiply each side by 20. We're going to get negative 60 over 100, which we can make into a decimal of negative 0.6. Okay, we have all of our numbers now. We have 0.25, negative 0.2, negative 0.6, and 1.1. Put those in order from least to greatest. My smallest number is going to be furthest in the negatives, coming out of the negatives, moving towards the positives, and into them. That would be your answer there. If it's easier for you to set these all up as fractions, you can do that. That's what we worked on yesterday. All right, writing decimals as fractions. A great way to do this is to read these decimals correctly. If you read these decimals correctly, it should not be too hard to put these into fractions. Watch what I do here. 43 hundredths. That's how I would say this out loud. 0.43, 43 hundredths. Wow, look at this. 43 hundredths, 43 over 100, 43 hundredths. That's a fraction, just like that. I just read it out loud, and I was able to put it right into a fraction. Super simple, super easy. Take a look at our next one. We have 1 in 12 hundredths. 1 in 12 hundredths. What can I write this as? 1 in 12 hundredths. Easy. We wrote that as a mixed number. Our last step is to simplify this. We got to find that greatest common factor, or the greatest common divisor of both of them. So I'm going to set up my trees here. This can be 6 and 2, and 3 and 2. This one can be 50 and 2, 25, 2, 5, and 5. Okay, so we got in common 2, 2, 2, 2. That's what they share. They both have a 2 squared, which is the same as 4. So I'm going to divide each by 4. And I'm going to get 3 over 25. My final answer is going to be 1 3/25. right away I was able to just quickly turn it into this fraction just by reading it out loud properly. Watch what I do with the next one. I'm going to do the same thing. 2 and 32 hundredths. That's how I'd say that out loud. 2 and 32 hundredths. I'm going to put that right into a fraction. 2 and 32 100ths. Easy. Last step, we just got to simplify this. We're going to do our prime factorizations again. I already have mine for 100 right here. I know it's going to be 2 squared times 5 squared. 32, let's do 8 and 4. Split that up into 2 and 2. Split this up into 4 and 2, and then 2 and 2 again. So we have 2 to the 5th. What do they have in common? Again, they both have 2 2's in them, which is going to be divide by 4, divide by 4. This is stuff that we worked on before Christmas break. If you need a refresher on that, might be worth going back and watching those lessons. Divided by each by 4, we're going to have 25 on bottom. We're going to have 8 on top. 2 and 8 25ths. All right, I know this lesson's getting a little lengthy. Hey, I know I cut off that video right there shortly. That's because I was teaching a method and I decided I wanted to teach it a different way. So I'm going to finish up this lesson, fresh sheet of paper here. We're going to keep cruising here. So now we're talking about writing a repeating decimal as a fraction. The key part is a repeating decimal right here. I think this is one of the coolest things in math right here is being able to convert this repeating decimal into a fraction. So as you know, this right here means this is repeating. So this would look something like this. Forever and ever and ever. So what we can do here to make this a fraction is for every repeating decimal, we can divide by a 9. So right here we'd have 2 repeating decimals, so I'm going to divide by 99. So watch this. What I'm going to do is I'm going to take this right here, put it over 99. That is going to make my decimal repeat right here. From here, all we have to do is we have to find the greatest common divisor of both. And I don't know why I wrote 99. I meant to write 33 and 3 underneath it. And then 11 and 3. 72. Let's do 8 and 9. 3, 4 and 2, 2 and 2. Our greatest common divisor here is going to be we have a 3 here, 3 here, 3 here, 3 here. So 3 squared or 9. So divide this by 9. It's going to be 8. Divide this by 9. It's going to be 11. 8. What am I doing? 8 elevenths would be your final answer there. So for every repeating decimal, in this case there was 2 of them, I just divide it by a 99. Divide it by 9 for each one. That's your key right there. This doesn't really explain a whole lot to why this works. If you're more interested in why this works, I'd love to talk about that with you in my office hours. I can show you some different methods of solving this as well. Actually, I might do that for one more method here at the end. I'll show you that if you want to hang around. Otherwise, I can tell you that you can hop off at that point. Okay, so we're doing our next one here. We have 1 repeating decimal, so we're going to just divide by 1 9. What we're going to do right here is we're going to take 6 and 9. And I'm going to take that 6 right here, make that a 3 and 2, take that 9, make it a 3 and 3. What is their common? Is that 3? And this is going to be the same as 2/3. Easy. Super quick, super simple. One more example here. We got 3 decimal places, so I'm going to do 9, 9, 9. Perfect. We got to find least common divisors. I don't really know what can go into this. I'm going to make this 3, 3, 3, and 3. Then make it, I think that should be 111 and 3. 111 divided by 3 again. It's going to be 37 and 3. And 37 is a prime number right there. 213, divide that by 3, we'll get 71 and 3. And 71 is also a prime number. So what's their common? They both share 1, 3. So we're going to divide each by 3, and we're going to get 71 over 333. That's your final answer. So for each decimal place that they have, you're just going to divide by that many 3's. If you had a repeating decimal that was something like this, 2, 5, 6, 7, 8. That was all repeating, then we'd go by this many 9's. If we have just that 1, then we divide just by that 1 9. For the rest, you do it the exact same way. If you'd like to hop off now, that is okay with me. I hope that these connected well. There's going to be 2 videos that you're going to have to watch. If not, I'm going to give you one more example here. This is going to be a little different example. That's going to explain the reasoning for this for those of you that are interested. I think this is super cool. You don't have to stay if you don't want to. Here we go. So what we can do here with a repeating decimal is I can set this equal to a variable. I'm just going to set it equal to, let's just do n. Okay? So now that we have this set up as an equation, which we're allowed to do, watch what I'm going to do. I'm going to multiply each side by 100. I'm choosing to do 100 because these are in the hundredths place, and I know that that will make this 54. 5 for repeating on this side, and this will make this 100n. Okay, now we got this figured out. Now what I'm going to do is I'm going to do something simple, and I'm going to subtract an n from this side, and I'm going to subtract an n from this side. 100 minus 1n is going to get us to 99n on this side. And on this side, we don't have any n's to subtract, but n is equal to this repeating decimal. So if I subtract an n, it is the same as subtracting a 0.54 repeating. And look at this. We have a 0.54 repeating right here. So I'm actually going to be subtracting 0.54 repeating. That's going to leave behind 54 on one side and 99 on the other. Final step, divide each side by 99. And we get 54 over 99, which we can simplify by dividing by 9. Because I know that is the greatest common divisor, and we will get 6 over 11 equals n. So that makes a little bit more sense of why we can do this, how it works. This other example is the quick solution, the quick, easy tip to get out of it. If you have more questions, I'd love to talk about it in office hours. Have a great rest of your day. Nice work.